Okay. The next rule we are looking at is the quotient. Now, it just helps us to differentiate the quotient of two functions, okay? Something like a rational function, okay? Good. So this is an example of a function which is going to make use of the quotient rule, okay? So we have one function on top and the other at the bottom, okay? And we make the function on top mostly u, whilst the one at the bottom is v, okay? So that you have the form y is equal to what? U over what? V, right? And then you apply the same principle, just like we did in the quotient rule. So once again, you make your numerator, which is 2x, okay, be equal to, so we let u be equal to what? 2x plus 1, okay, and then let's v be equal to what? The denominator, okay, which is 5x squared, okay. Then we'll differentiate u with respect to x. So the u dx will give us 2, and the v dx will give us 10x. Okay, good. Then what's next? We are just going to substitute into this formula. Okay, and if you look at it carefully, right, we're going to pick v first. So v is what we have here. Okay, so let me just change the marker. This is v, okay. So we pick v first, which is 5x squared, okay. Then we go for the u. The u is what? 2, okay. So that is times 2. Okay, that's the u dx is 2. Then minus, we go for u. U is what? 2x plus 1. So that is 2x, okay, plus 1. Then you go for dv dx, okay. So what is dv dx? Dv dx is, okay, this dv dx, that is 10x. So times 10x here, right? All over. Then we bring our v squared. This is v, so that's 5x square, all square, okay. So that is the substitution we're going to make, okay. Then after which we'll have to simplify. So let's go to the solution on the next page. Okay, so that is the substitution we just talked about. And then once we expand from here, we are going to get 10x squared, okay, minus 20x squared minus 10x over 25 x raised to the power 4. We simplify further, this gives us what? 2x, okay. If we wish, this give us what? Minus 30, okay, minus 30x squared, okay, minus 10x, and the denominator is also what? 25, okay, 25x cubed, right? But as we are aware, okay, we have 5 common to both terms, 5 common to the denominator. So we can factorize what 5 out here. X is also common. So 5x. We have minus what 6 minus 6x minus 2. Okay, in bracket over what? Oh, sorry. This is positive 10, not negative 10. Okay, so this will rather be instead of 30, we have negative 10. Okay, that's a little correction we have to make. So it's not 30, it's rather 10. Okay, so one we factorize, we get negative 2 in bracket. Okay, negative 2x over 25x. Okay, raised to the power 4. Right, 5 can go here 5 times, cancels out this, and x goes here and cancels out this, x raised to the power 3. Okay, good. So that will give us a very simple answer, which will be what? Minus 2x, okay, minus 2 over 5x cubed for the very final answer, okay, to this problem. Okay, now at this juncture, I'll ask you to so let's take the function y, okay, y equal to say 5x, okay, raised to the power 4 divided by say 2x raised to the power 3 minus say 2, something like that. Okay, so once again this becomes of the form u over what? Over v, right? So we let u be the numerator, which is what? Which is 5x raised to the power 4. Okay, and then v be what? 2x cubed minus 2. Okay, good. Then what next? We are going to differentiate. So let's differentiate u with respect to x, okay, which is equal to what? 4 times 5x raised to the power, okay, 3, and we have dv dx will be what? Will be 6x raised to the power 2, okay, because the derivative of a constant is 0. So this here will be 20x cubed, okay. Maybe we should have done that in the previous step. So let me just go and simplify that here. This is 20x cubed, okay. So then we make use of the formula. Formula says that dy dx equals to what? Will be v. So we go for v first. So which will be 2x cubed, okay, minus 2. So that is v, okay. Then we go du dx, okay, which will be du dx here, which is 20, okay, 20x cubed. I think we don't have enough space. Okay, so let me just clear this out. So let me restart everything. So dy dx, okay, will be v du dx, which will be 2x cubed okay, minus 2 times du dx, which is what? 20x cubed, okay, minus, we have what? U, so we are going for U this time. So that will be 5x raised to the power 4. Then we have div dx, which will be what? 6x squared, okay? You get it. So this is v du dx, okay, v du dx minus u dv dx, okay? So that is what we have just done here. Then we need to divide through by what? V squared. So that also will be, v is 2x cubed minus 2, okay, all raised to the power what? All raised to the power 2, okay? Good. Yeah. Yeah, so from where we can simplify the expression, that will give us, when we expand what we have here, okay, that should give us 40, 40x raised to the power 6 minus what? Minus 40, okay, x raised to the power 3, then negative 30x raised to the power 6, okay, negative 30x raised to the power 6 all over 2x cubed, okay, minus 2 raised to the power 2, okay. Yeah, that too can be expanded, but I'm not going to expand that. When we simplify the numerator, we get 10x raised to the power 6. We have 40 and 40x raised to the power 6 and minus 30x raised to the power 6. So that gives us 10x raised to the power 6 minus 40x raised to the power 3, okay, over the denominator, which is what? 2x cubed, okay? That gives us 2x cubed minus 2, okay, all raised to the power what? All raised to the power 2, okay? Good, all raised to the power 2. So that will be our final answer for this particular derivative. So the initial steps are what matters very much, okay, making the numerator u, making denominator v, and then following through with the principle is very important. Okay, now let's take some questions. With compound functions like what you have here, we cannot use any of the rules we just applied, okay, because these are compound functions. Okay, compound in the sense that, you see, this function in here is a function on its own. So we could have written it as y is equals to x cubed, okay? And this is also another function, which is y is equals to sine, okay, of maybe, let's say u. You understand? So there are two functions which have been combined. So if we say that u is x cubed, and then we come and put x cubed inside the sine function. Sine is a trig function, and x cubed is a polynomial function to the degree 3, okay? So there are two functions that have been combined. In the same way, when we come to this function, this is an exponential function, e raised to the power u, and then another function, which is a linear function, 3x plus what? 2, okay, have been combined to give you what we have at the top here. The same way, when it comes here, we have the function u, square root of u, and then u is equal to what? X squared, okay, minus 1. So all these functions, these compound functions, are a combination of what? of two functions, sometimes more than two functions. Okay, good. How do you work them out? And we are saying that it's very simple. Okay, to work out a compound function, the principle is very basic. Let one of the functions, as we have done here, let one be equal to u. Okay, so that the function will be of a reduced form. So in this case, if you let what is in the bracket be equal to u, then it means I will be left with y is equals to what? Sine u. Okay, and then if you let this also the power be equal to u, okay, this be equal to u, that's 3x plus 2 equals to u. Then which means that we are left with what? Y equals to e raised to the power u. Okay, and the same way, if we let what is under the square root be equal to u, then we'll be left with the function y is equals to what? Square root of u. Okay, this is what the compound, or let me say the chain rule, okay, is all about. Then what it says is next, you are going to apply the principle. We'll see that in the next slide. So if you want dy dx, it's just going to be, you see now you have two functions. So just like we did for the other functions, you are going to differentiate y. This time y is a function of u here. Okay, so y with respect to u, okay, times, then you differentiate u also with respect to x, so times du dx. Okay, and once you do that, you get your dy dx. Okay, technically, I'm not saying do cancel out, but technically when you look at this, the denominator will cancel the numerator here, so it's still the same as dy dx. Okay, so what we are saying here is if they are the same or the equivalent, then it means that we can differentiate y with respect to u and u also with respect to x and multiply them. Once we multiply them, you get your solution. Okay, good. So let's take some few examples to this. Yeah, so we have the principle. We take a question like this. Okay, so the first question we have here is y is equal to what? 2x plus 1. Okay, raised to the power what? Raised to the power 3. Okay, good. And we are saying that anytime you are giving something like this, okay, make one of the functions be equal to what? U. Okay, so we'll let whatever is in the bracket be equal to u. Okay, so we have u is equal to what? U is equal to 2x plus 1. And then which will mean that y will be equal to u raised to the power 3. You understand? Then let's differentiate u with respect to x. So u with respect to s will give us what? Will give us 2. Okay, we are differentiating this with respect to s. Then let's differentiate y2 with respect to u. Okay, y is a function of u, not x. Okay, so we'll differentiate with this with respect to u. We'll get 3 u raised to the power 2, right? Then just come and apply the principle for differentiation. So dy dx will be equal to dy du, which is 3u squared. Okay, so 3u squared times du dx, which is what? 2. So this will be equal to what? 6u squared. Okay, but we said u is what? 2x plus 1. So just come and substitute it in, and you get 6 times 2x plus 1 raised to the power 2. And that's the final answer. Okay, I think it's quite simple. Let's try another one. Okay, just for us to understand better before we ask questions. So let's try another question. Let's say this time we have y is equal to, let's say 3x squared, okay, plus 1, or raised to the power half, okay. Yeah. So it's the same principle. We'll let u be what is in the bracket. So we let u be equal to what? U be equal to 3x squared plus 1. And then v be equal to what? V be, once this whole thing is u, y be equal to what? U raised to the power what? Half. And apply the principle of differentiation. So the u dx will be equal to what? Will be equal to 6x. We have 6x. And then the y dx, the du, okay, will be equal to what? Half. Then half minus 1 will be minus half, okay? Half minus 1 is minus half. So raised to the power minus half. Then apply the principle. Dy dx will be equal to dy du, which is half u raised to the power half, okay, times what? 6x times 6x, which is du dx, okay. Good. And this simplifies to be half cancels out, 6 will get 3, okay. If you like, u raised to the power minus half, okay, x. But we know u is what? U is 3x squared plus 1, okay. So when we substitute that in, we'll get 3 times what? 3x squared plus 1, okay, times x, right? But there is a raised to the power half here, so we have to put it there. So that's raised to the power minus half, okay, good. Now we know that any number raised to the power negative of something is 1 over, okay, that number raised to the power the positive of that thing, right? So this can be re-expressed as what? 3x, okay, divided by what? 3x squared plus 1, okay, all raised to the power half. So that would be the final solution for dy dx. Okay, so at this point, I'll take any questions if there are any. Okay, so this will be the very final example on this aspect. We have y is equals to square root of 3x squared plus 5, okay? And I guess by now, you know exactly what we are going to do, okay? So we'll let what? We'll let u be equal to what? What is under the square root, which is 3x squared minus 5. And then y will be u raised to the power half, okay? Then we differentiate y with respect to u, and u also with respect to what? X, okay? Then after that, we multiply the two, okay, using the chain rule. So that will give us half u raised to the power negative half times 6x. And that simplifies into what? 3x u raised to the power negative half. Okay, put back your u into the equation there, and then you get this, okay, which will simplify into what? 3x over square root of 3x squared minus 5. Very similar to what we just looked at. Good. So that brings us to the end of chain rule as well. More examples on chain rule. Let's look at this also. Okay. So here we let the denominator, what is in bracket, be what? Be u. So this becomes u, okay? So u is 7x raised to the power 3, and then y will be 2 over x raised to the power 4, okay? But that can be written as 2x raised to the power minus 4. Then when we differentiate, okay, y with respect to u, you should get negative what? 8u raised to the power negative 5. Then differentiate u with respect to s, you get minus 3x, okay, raised to the power 2. Then after that, multiply the 2. When we multiply, you should get positive 24 s raised to the power 2 over times what? U raised to the power negative 5. Then replace your u back into the equation, okay, and re-express it. So put u back, u which is 7 minus what? 3x squared back into the equation, okay? Then you re-express it, okay, to give us 24x squared over 7 minus x raised to the power 3, all raised to the power 5. So that is for the chain rule. Now, the very final thing we are going to look at before we end of today's class will be the concept of implicit differentiation. Okay, good. Now, when we talk about, I think this example is more examples for you to try at home. Okay, good. So that brings us to the conclusion of one class. Okay, in the next session, we'll be looking at implicit differentiation. Okay, implicit differentiation. So I think we'll pause here, right? What we've done should be enough for today for an introductory, okay, topic. Just work on all the examples in the slide. Then by the time we meet next week, I'm sure you would have mastered the very basic concept of differentiation. Then we proceed from there, okay? In the next class, we'll be looking at implicit differentiation and the differentiation of other functions like the trig functions, the link functions and all that, okay? And then we'll review the concept of product rule, quotient rule again, combining the various functions, okay, with linear functions to determine the derivatives. Good.